Okay, by definition, the cardiac cycle is all the events that occur in one heartbeat. We're going to use 75 beats per minute as our normal heart rate. So typically a normal heart rate is anywhere between 60, maybe all the way up to 80 at rest. And if you did the math, each cycle would be zero point 0.8 seconds long. So if you were to think about, let's think about what a 60 beats per minute heart rate would be. Well, you got 60 beats in a minute. A minute has 60 seconds, so that means each beat would last a second. So if you're going to have more beats than 60, that length of the cycle must be shorter than a second. Okay? So all these events that we're going to cover in the next 3 slides happen in less than a second, 0.8 seconds. Okay, so we're going to break down the cycle into 3 events. We're going to have atrial systole, so that's the period in which the atria are contracting. Then we're going to enter what's called ventricular systole. That's when the ventricles are contracting and the atria have relaxed. Then we're going to enter what's called relaxation, and that's when the ventricles relax and the atria are still relaxed. Okay? So we're going to use this as our normal EKG so that we can kind of figure out where we are using an EKG. So we know that the P wave is going to be basically the start of a cycle until we get to another P wave. Let's say there's another P wave over here. All right. Now notice this image kind of breaks it down. So we're going to have the P wave, right? Atrial depolarization. That's going to lead us into atrial systole. So from P wave up until the Q, or QRS, is when the atria are contracting. The QRS is going to be ventricular depolarization. So that's going to start the ventricular systole, right? And at the same time, the atria relax. So notice we have the atria contract, then they relax. We have the ventricles have been relaxed up until the QRS, and then they contract. And then at the T, the ventricles relax. So from here, from P wave up until the QRS is atrial systole. From the QRS up until the T is ventricular systole. And then after the T up until the next P wave is relaxation, because everyone's relaxed. Okay? All right, so let's start. What's going to start this whole process off? It's going to be depolarization of the SA node, the pacemaker. All right, so that's going to be on this EKG this moment right here before the P wave. All right, because once the SA node depolarizes, it's going to spread through the atria and cause atrial depolarization. So we get the P wave. All right. Step 2, what does atrial depolarization do? Well, we already know. Depolarization causes contraction. So it's going to cause the atria to enter systole, all right, which is contraction. Okay? What does that do? Well, that's going to raise the pressure in the atria. All right? So these 3 steps always happen in this order. You're going to get depolarization, you're going to get contraction, and then you're going to get an increase in pressure. So what does that increase in pressure do? It's going to move blood. All right? It's going to allow blood to go from the atria down to the ventricles. Okay? And this is a point that's a little confusing, but we'll come back to it. The valves are already open. All right? The valves opened towards the end of the previous heartbeat. All right? So we're just opening them up, or they're already open, I'm sorry. We're just adding more blood to those ventricles. I call this topping off the ventricles. Okay? So then the question is, well, how much? So now we're going to talk about a little bit of volume. During atrial systole, we add about 25 milliliters, which is about 20% of the total volume that's going to be in a ventricle. So what that means is there must have already been blood in the ventricle, okay? And that blood, in this case about 105 milliliters, occurred prior to this P wave, all right? So prior to the P wave, we were towards the end of a cycle. We started to refill, all right? So when the heart ejects blood, it's going to start refilling even before the next cycle, all right? So by the time you get to a new cycle, you've got about 80% of the volume in your ventricles. So therefore, when we go through the atrial systole, you're just adding another 20%, in this case, the 25 milliliters. This also explains why atrial fibrillation isn't necessarily life-threatening. Because if you have AFib, you might not get this 20%, but you still have this 80%. All right, so you're still going to be able to pump blood, even though the atria might not be functioning. All right, so if you add 25 to an already present 105, that's going to mean you have 130 milliliters in each ventricle. That 130 milliliters at the end of atrial systole, at the end of ventricular diastole, right? Notice where we are. We're right here. So we are at the end of atrial systole, but also at the end of ventricular diastole. So the ventricles are done being relaxed at this moment. The atria are done contracting. The volume that's in that ventricle, the 130, has a name. It's called end diastolic volume. All right, now think about what that means. We're at the end of diastole. All right, we're talking about the ventricles, okay, because that's where the blood is. So when the ventricles are done being relaxed, whatever volume is in that ventricle is called end diastolic volume. And in our case, it's that 130. So what are all these numbers? These normals are just normal. All right, it could change from person to person. So this is typically kind of a normal resting heart, pumping a normal amount of volume. Okay. All right, so what did we do during atrial systole? We basically added 20%. All right, we kind of topped off the ventricles. They now have kind of what I would call full, right? They're full. They each have 130. Now the job of the heart is to pump and eject blood out. All right, so we're right here. What's going to happen? Well, we have the QRS, and we're going to switch. The atria are now going to relax, and the ventricles are now going to contract. So ventricular systole starts when the ventricles depolarize, depolarization of the ventricles. We see that as the QRS. We know that when ventricles depolarize, they're going to contract. So we're going to enter ventricular systole, shown by this arrow. What's that going to do? Well, it's going to raise the pressure. So now we raise the pressure in the ventricles because they contract, and that's going to close the AV valves. So notice that's like the first event that occurs, is you want to immediately close the AV valve so blood doesn't go backwards. And remember, closing of the AV valves is associated with the first heart sound, S1, or the lub of the lubbed up. So we close the AV valves. We enter what's called isovolumetric contraction because everyone's closed now. The semilunar valves are closed, and now we've just closed the AV valves. What that allows us to do is really ramp up the pressure. So the pressure dramatically increases in the ventricles until we can open the semilunar valves. Once the semilunar valves are open, we can eject. All right, ventricular ejection. How much do we eject? All right, That volume that's ejected, now remember, how much was there? We had 130. All right, we had that end diastolic volume, that 130 milliliters. We're going to eject a portion of that. We're not going to eject the entire volume. So normally you're going to get about just over 50%. All right, so that volume that is ejected from each ventricle, the right's going to eject the same volume as the left, is called stroke volume. All right, and in our case, that's the 70 milliliters. All right, now what pressure does that take? The left ventricle's got to get up to that, 120 to eject its stroke volume. The right ventricle has to get up somewhere around 25 or 30. All right, so it takes different amounts of pressure to eject the same volume. All right, so we just ejected. All right, what did we leave behind? We left behind about 60 milliliters. Remember, we don't eject the entire volume. We inject about 50-55% of it. So we leave some blood in there, and that volume, that 60 milliliters, is called end systolic volume. So end diastolic was when it was full, and systolic is now when it ejected the 70. So you can do a little math here, right? If you had 130, you ejected 60. So if you take 130 and subtract, you ejected 70. If you had 130, you subtract the 70 that you ejected, you're left with 60. All right? So now what? Well, now let's start to refill. So now when we enter relaxation, so now the ventricles are going to relax, the atria are still relaxed, that's going to allow us to start to refill the ventricles. All right, so we're going to call this the relaxation period. All right, and this is the period that'll change. So the faster the heart beats, the shorter the relaxation period. The slower the heart beats, the longer the relaxation period. But we're going to start with the T wave, right? Notice the T wave lines right up with ventricular diastole. So the repolarization of the ventricles, the T wave, causes the ventricles to relax. Relaxation of the ventricles causes the pressure to go down, right? If contraction causes pressure to go up, it should make sense that relaxation causes the pressure to go down. If we drop the pressure in the ventricles, blood's going to want to come back in, right? Blood's going to want to go wherever there's a lower pressure. So we got to prevent that blood from coming back in. So that blood actually pushes back onto the semilunar valves and closes them. All right? So we close the semilunar valves. We can hear that. All right? Second heart sound, the dup of the lub dup. There's a little bit, we're going to talk about this on another slide. There's a little drop in the aortic pressure that we can see. Not as important to us right now. But we're going to close those semilunar valves. Now we've got all the valves closed again. So there's another period where all the valves are closed. But during this period when the valves are closed, we're relaxing the ventricles. And if we keep relaxing those ventricles, the pressure really falls very low. And if the pressure in the ventricles drop below the pressure in the atria, that's going to open those AV valves back up. All right? So we want to reopen those AV valves so we can start to refill those ventricles. All right? And that's called passive ventricular filling. It's our ability to start to refill the ventricles when everyone's relaxed. The atria are relaxed, the ventricles are relaxed, the AV valves are open, and now we can start to refill. So what did we have in there? We had the 60. We had that end systolic volume. Now we're going to start to refill with about 45 to get us back up to that 105 that we already had in the ventricles before we reached atrial systole. All right. So this is, again, what we call passive filling, because none of the chambers are contract. We're just kind of refilling those ventricles. So that gets us up to that 80% again. Then we do it all over again. Top it off with another 20%, eject, start to refill again. So those are all the little events that occur in one cardiac cycle. Do you need to memorize all this? No, but you should understand why one thing leads to another. You should know when the valves open. Why do they open? When do the valves close? Why do they close? When does blood fill the ventricles? When do we top off that ventricle? When do we eject the ventricle? There's some names associated with volumes. What do we mean by stroke volume? What do we mean by end diastolic volume? What do we mean by end systolic volume? So there's a lot of information on these previous 3 slides. There's also graphs that might help. All right, so this graph is just showing us pressure. All right, so what we're doing is we're kind of starting. Okay, we're going to start. We can start right here. All right, and we can just look at pressures. Okay, so if we start right here, we're in atrial systole. All right, so remember what atrial systole means. The atria are contracting, so they're going to have a relatively high pressure. Notice that this gray line is atrial pressure. All right, the blue line is ventricular pressure. So if the pressure in the atria is greater than the pressure in the ventricle, you could fill that ventricle. So that's when we're kind of doing that additional 20%. Notice right here, all of a sudden the ventricular pressure goes up. All right, what does that do? That's going to immediately close the AV valve, in this case the mitral valve. So this is the start of that ventricular contraction. Pressure goes up in the ventricle, close the AV valve. Pressure keeps going up, 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 up. We're in this isovolumetric contraction. All of a sudden, the pressure now in the ventricle goes above the pressure in the aorta. All right, so this top line up here is the pressure in the aorta. So think about it. If the pressure in the ventricle now goes above the pressure in the aorta, that's going to open the aortic valve. So that's the moment we open the aortic valve. As long as that aortic valve is open, you can eject. All right, so we're going to be ejecting. And the pressure is going to keep going up in that ventricle. Notice what happens once the pressure in the ventricle starts to drop. Once the pressure in the ventricle drops below the aortic pressure, we close the aortic valve. So the aortic valve opened here, we ejected, it closed here. Then the pressure drops in that ventricle because we're relaxed. And if the pressure in the ventricle drops below that atrial pressure again, the mitral valve is going to reopen. All right? So this graph might make things more confusing for you, or it might help you understand why valves open and closed. So that's what I would use this for. I would think about what happens right here, right here, right here, and right here. So that's going to explain why valves open and close. All right? Why does the mitral valve close? Because the pressure in the ventricle is above the atria. Why does it open? Because the pressure in the ventricle is below the pressure in the atria. Why does the aortic valve open here? Because the pressure in the ventricle is above the pressure in the aorta. Why does it close? Because the pressure in the ventricle goes below the aorta. Okay? So again, it may or may not help you, but it's just one additional piece that might make things a little more understandable. And then these are the labels here. So notice that I just kind of labeled the key components of this graph. All right. There's some other little waves. I'm not going to hold you to these A, C, and V waves. That's a little more than we need to do. But if you're trying to make sense of the valves open and closing, this is a pretty good graph representation. This graph shows you volumes. So if the volumes are giving you trouble, this would be a graph that could help. So notice this red line is the ventricular volumes, okay? If you go back and look, we started at a volume of 120, all right? We had about 120, I'm sorry, 105. We had 105 in that ventricle, okay? Then we topped it off, right? We had 105. We topped it off with the 25. So there it is. There we go. Okay. We started with 105 prior to atrial systole. So that's right here. When the atria contracted, we added the 25 to equal 130. So now we see that line go up to 130. Okay. Notice where we are. We're between the P and the QRS. So we're in atrial systole, where we added that 25 milliliters. Then we ejected, right? So when you eject blood from the 130, the volume in that ventricle goes down, okay, because we removed blood from it. So if you subtract the stroke volume from the end diastolic volume, which is the full, so that's right here, you're going to drop down to the 60 in that ventricle. All right. So again, we're just using a little math here. You're at 130, you're full. You ejected 70, you're left with 60. So now you're down here. All right. We want to get from 60 back up to 105. So this is that passive filling that occurs during relaxation. So everyone's relaxed here. So we're going to passively refill back up to the 105. All right, and now we're right back where we were over here. We're at the 105. We add the 25, and then we eject again. All right. So again, this graph may or may not help you, but it shows the volume changes that occur in the ventricle during a cycle. This shows everything. So every book's got this, where they try to line everything up. Again, this may or may not help, but you'll notice that up here we have the ECG or EKG. Here we have those pressure changes. Here we have the volume changes. Here we have the sounds that occur. Those are the two heart sounds. And then here are some pictures that kind of line up with each of those phases. So use this if you want. I know it's a lot. It's showing multiple things simultaneously, but sometimes it's easier to see everything all at once. Okay, I think we're going to do one more video. So we're going to stop this one. The next video will be our last video, where we talk about a little bit more about the volume changes and some of the measures of heart function, and then we'll get into regulation of the heart, whether it's nervous system regulation or things that might influence that cardiac cycle.